Welcome, everybody. Great to have you with us here today for our webinar on ductless heat pumps. My name is Joe Wachunas. My teammate in the fellow Electrify shirt there is Brian Stewart. And then we'll be joined by Tim Sharp from the Heat Pump Store and Len Crawford from Daikin North America today. So great to have you with us. If you want, go ahead and throw in the chat where you're listening in from today. We always love to see where our listeners are coming from. You'll see the chat at the bottom of the screen. We are Electrify Now. For those of you just joining us for the first time, we're an all-volunteer organization that believes in electrification. We try to boil it down into 4 steps. Number 1 is get that clean electricity in your house through solar panels or buying your clean electricity from your utility or community solar. Today, we're going to be talking about electrifying your home, and a big part of that is the space heating and cooling. So we'll be talking about ductless heat pumps. Of course, electrifying your ride, get that electric vehicle or electric bike. And then we're going to be talking shortly about electrify everyone, expanding the electrification to everybody. So great to have you with us. A big shout out to our Electrify Coalition members. This is our growing group of organizations that believes in and promotes electrification. We wanted to give a shout out to our new members as well. And thank you to all our members. If you're interested in being a member, please email Brian or I. You can find our emails on electrifynow.net. The last thing we wanted to do to take care of some business is to thank you all for donating, as always, to our Electrify Everyone program. Remember, we're all volunteer. We just try to raise funds for great organizations. And we've set up this program with another nonprofit, the Community Energy Project, to take out old and dirty natural gas water heaters and replace them with heat pump water heaters that are clean and efficient in income qualified households. We've replaced over 40 water heaters together. Just through these webinars, we've raised over $2,200. I'm going to put the link in the chat. Thank you for your donations. All these donations go to this program and to help serving these people in need. So thanks so much. With that, I will, one last point of business, upcoming webinars. We've got 2 in August, one on home backup power. You don't want to miss this. It's going to be on batteries and resilience and electrification. That'll be on August 18th. Then we're going to be doing one to celebrate the hang drying laundry week with low impact laundry on heat pump water heaters and front load washers. And then don't miss in September, the future of natural gas, how we can decarbonize if it's possible. That'll be exciting in September. So let me turn it over to my teammate, Brian.
All right, thanks, Joe. I just want to remind people what we're going to be talking about today. You probably saw this in the Eventbrite, but we're basically going to be talking about what are the best applications for ductless heat pumps? Will they work in my climate zone? How do I choose contractor? We want to make sure people understand what to look for when they're looking for either a contractor or a new product, and how to understand some of this complicated jargon like SEER ratings and other things. We'll be talking about that. There are some situations where you might be augmenting a current system with a ductless heat pump, so we'll touch on that. And then, of course, costs and incentives. And we're really fortunate to have 2 awesome people with us. You know, Tim, who's done tons of these installations, and Len, who is working for really the leader in this industry. So Len will be talking to us a little bit at the end about what's going on in the industry with heat pumps, and why I think what you'll find is a lot of that gives you confidence that this is a technology that's not only been around for a long time, but that is going to continue to just get better and better every year. So a lot to cover today, but if we just kind of back up from the start here into why are we talking about this in the first place? I think it's always good to remind ourselves why these solutions are so important. And in this case, it comes down to natural gas. And a lot of people are using natural gas for heating in their homes. And when you add up all the natural gas that's used in the United States, it's responsible for about 1/4 of the emissions that come from our country. And a lot of that is for heating in our homes. In a typical home in the United States is going to consume about or produce about 5 tons of emissions from the natural gas that we consume in our homes. And it really comes down to primarily your furnace. If you have a gas furnace in your home, on average, it's going to be about 3 tons of emissions per year. More if you're in a cold climate in a large house, less if you're in a warmer climate or in an apartment, let's say. The water heater is surprisingly close in terms of the emissions that come from that. And that's because we use these devices, every day, all year round. But again, this can vary a lot from home to home. But if you are in a home that had teenagers like we did for a while, it will be well over 2 tons. If you're, single or maybe don't take a lot of hot showers, it could be less than this, but on average, it's about 2 tons. So we're going to be talking about gas furnaces today, or replacing them with ductless heat pumps, and why that's an advantage. I know these numbers, like a ton of carbon, that's hard to get your brain around. So if it helps, here's one way to think about that. Imagine you and I are walking down the street and we come across this pile of plastic in the street, like 100 plastic bottles and 100 plastic bags and 100 forks and 100 spoons and 100 knives and 100 of those plastic takeout containers that we're all familiar with, and maybe 100 plastic yogurt cups on top of that, and sprinkled in 1,000 plastic straws. So imagine we saw this huge pile of garbage in the street. It's plastics waste, and we'd be horrified. But I think most people would be even more horrified to find out that the carbon emissions from that is dramatically less than the carbon emissions from typical heating loads in our homes for water and gas, so water and heat. So if it helps you, think about essentially generating a big pile of plastics waste like that every day that we use our gas furnaces and gas water heaters. So yeah, that's why it's really easy to get excited about these really super efficient heating and cooling devices, ductless heat pumps, that use a lot less energy to begin with. But then, as Joe mentioned, if we are, particularly when we have clean electricity in our homes, it means you can get close to zero emissions for your heating, which is awesome. I mean, here in Oregon, we just passed a bill that's going to require that our electricity is 100% renewable by 2035, I believe is the date, which is fantastic. But pretty much everywhere in the country, here in the United States, these super efficient electric heat pumps are going to produce far fewer emissions than gas does. So that's why we're excited about them from a carbon emission standpoint. And these guys are going to talk to you about why there's other reasons to be excited about it in terms of comfort and other features. So with that, I'm going to introduce our speakers here. We have Tim Sharp from the Heat Pump Store. The Heat Pump Store is one of our coalition partners. Really happy to be associated with them. They're one of the leading installers of ductless heat pumps in the Pacific Northwest, and they've worked with pretty much every major brand. So they know all the ins and outs of pretty much every situation and every product that's available. Tim's been working as a contractor for over 25 years and been at Heat Pump Store for 6 years as a Ductless Specialist. And because the Heat Pump Store focuses on ductless heat pumps, I mean, there are many different kinds, but ductless is one of the major categories that we're going to talk about today. And the Heat Pump Store works almost exclusively in that area. So they're super proficient in that. So happy to have Tim here on the show, and he's going to lead us out. And then Len Crawford from Daikin, he's an account manager for distribution in Daikin North America. And if you're not familiar, Daikin is the leader in this space, in this industry, and is responsible for pretty much most of the innovations that have happened, and responsible for continuing to push the needle on making these devices more and more energy efficient and more higher performance every year. Len has 25 years of experience in this area, and so I'm super excited to have him as part of the program today. So we're going to turn it over to Tim here and get us started. So take it away, Tim.
All right. Thank you, Brian and Joe. Great to be here and happy to talk about ductless heat pumps. So let me get a full screen here. Hang on one sec. Okay, so everyone hear me okay? I'm a field rep for the Heat Pump Store in Portland, Oregon, USA, and I can speak from a local perspective on ductless heat pumps.
Len, we're not seeing your screen yet.
You're not seeing my screen. Okay, let's see here. Sorry about that. Can you hear me okay?
just go to that share screen button at the bottom if that works, Tim. And while you're doing that, I'll just remind folks, we've got the Q&A. Folks are already putting questions in the Q&A. That's a great spot so we can track all your questions, and we'll get to them at the end of the program.
Sorry about this, a little technical difficulty, just a minute. Here we go.
There we go.
Okay, sorry about that. Okay, so moving right on. Here's today's menu. What in the world is a ductless mini split heat pump? We'll talk about choosing a system, choosing a contractor, and of course, energy and the environment. So jumping right in, here's a first look at what we're talking about, a ductless mini split heat pump. The image shows the outdoor part of a split system with the components split between the outdoor unit shown and the indoor units, in this case, are in the living room and bedroom. And they're not shown, right? So this is a 2-zone heating and cooling system. And the lines, as they're called, running along the exterior of the house, transfer heat using refrigerant rather than running hot or cold air through ducts. So this heat pump is both split between indoors and outdoors and ductless. The lines can be concealed in line height, as you're seeing here, or they can run through attics, basements, crawl spaces, and sometimes inside walls. So the main points are that mini splits are not a unitary or packaged system. For example, with an AC, window AC unit or a central furnace. They're ductless, so we're not running air through ductwork as in a gas, oil, or other central system running forced air. And it's a heat pump, so it's using outside air instead of burning fossil fuels. So on the left here, you see the refrigerant lines connected to the indoor unit along with some electrical components. And the image on the right shows an example of what we call a high wall indoor unit. It ideally replaces the baseboard heater you see at the bottom of the image. These are both electric-based systems, but the heat pump has what we call a coefficient of performance that is more than 3 times better than the baseboard heater, because it is collecting and pumping in heat from outside rather than using straight electricity to create that heat. Heat pumps are used worldwide in existing residential homes, multifamily properties, commercial and new construction projects, anywhere, and is in this case, sometimes everywhere, heating and cooling is needed. So how do they work? How do you get heat and even cooling without burning something? And how do you pump heat, right? So heat transfer. In the beginning, people collected ice for refrigeration, and they subsequently got an A+ for being environmentally friendly with their cooling system. So with ductless heat pumps, we're focused on heating and cooling using the property of heat transfer. So heat expands out from high concentration to a colder area of low concentration. You've heard that heat rises, right? It expands out. So think of getting out of a hot shower and you feel cold, or think of the coaster you put under your ice water on the table. That's the room's humidity condensating on your glass, right? So these are examples of heat transfer and not burning a fossil fuel. Some technical terms in this area are convection, radiation, or conduction, okay? So a little history. In 1834, a gentleman named Jacob Perkins is credited with building the first practical refrigeration machine using ether in what is called the vapor compression cycle. Another way to think of this is a refrigerant pump, okay? In Jacob's case, he used ether as the refrigerant, and as it cycles between the liquid and gas states, heat is collected and moved as a consequence. And consider your refrigerator, okay? You know the sound it makes, brrr, right? Simply put, that noise is a compressor squeezing the refrigerant, which collects heat inside of the refrigerator box. The heat's then pumped out the back of your refrigerator. And if you were to run this heat pump cycle in reverse, heat would be collected from the room and collected inside of the box, cooling the room. So reversing this cycle is how a heat pump can either heat or cool a room. So Daikin began marketing mini splits in the 1950s and was the first manufacturer to introduce a multi-split system, something we'll talk about later. In my work at the heat pump store, we sell or have sold systems from LG Electronics, Haier, Daikin, Fujitsu, Mitsubishi, Panasonic, Payne, Carrier, and Ruud. So there's 100 brands to choose from. Obviously, Daikin is one of my favorites and the brand that I sell the most. So here's our new and improved refrigeration cycle, today's ductless mini split. Here's an image of your typical window air conditioning unit, what we might call a window shaker. It is not split, so it has a combined compressor and evaporator in one box. It also takes up the window, generates heat while it's trying to cool the room. It's noisy and it's too small for a good volume of air exchange. And here's an image of your typical rollaway AC unit. Again, it's not split. It simply takes up the room instead of the window. And here we have an example of, again, your split compressor and evaporator. So the compressor is outdoors, the evaporator is indoors. Some benefits, of course, are that it locates the hot, noisy mechanical components outside. It allows for much higher volume of air separation for better performance. It clears the equipment from a window, and it has a reversing valve for both heating and cooling. Next here, of course, we're looking at a central gas furnace. It uses fossil fuels for heating and moves heat through ducts. Sometimes a conventional heat pump, as distinguished from an inverter heat pump, is added to these kind of systems to add heating capacity or to add cooling. And it occurs to me that if you have a duct like this on the left, you may have trouble with a duct like this on the right. Just joking here, of course. But note that no heating and cooling systems bring in outside air unless it's designed into the system. Whether it's forced air or ductless, these systems recycle and hopefully clean the indoor air. And it's an important note for smoke events and fire season. Fire season might be our 5th season of the year between summer and fall here in Portland, Oregon. Okay, so heat pumps use copper tubing, also known as refrigerant lines, to move heat and not air. And here's back to our inverter versus conventional heat pump distinction. A new title might be a ductless inverter mini split heat pump, and that's certainly a mouthful. Or maybe we should make it an acronym of DIMSHIPS. I don't know. Anyhow, the point being that both of these systems facilitate heating and cooling through refrigerant lines, but the compressor in the inverter system, shown to the left, operates in a continuous cycle, and conventional systems are stage, or they gear up, okay? The analogy I like is having a car sitting at a red light. The light turns green. You can either put the pedal to the metal or you can take off slowly. The inverter system would be taking off slowly and saving energy. Okay, so again, ductless systems don't use fossil fuels to provide heat. They run on electricity, and they don't use gas or oil for heating. Here you're reading about Daikin's Aurora, or extended capacity inverter system. It'll heat down to -13 degrees Fahrenheit and cools in temperatures up to 115 degrees. It is a real performer. So what's a ductless heat pump? Some other benefits include humidity control, which is really helpful if you have server rooms, grow rooms, or if you're making a big steamy turkey dinner. Zone control is an important factor because you don't necessarily need to heat unused spaces, or you can change temperature between rooms. And of course, there are what we call single zone and multi-zone options. They're easy to install. They don't require ductwork, so they're great for remodeling, for accessory dwelling units or ADUs, for tiny homes, used in new construction, manufactured homes, multifamily dwellings, and in light commercial applications. Okay, so moving on to topic 2, choosing a system. First of all, I want to talk about some of the basics, okay? An obvious question is it powerful enough? So will it fit the room? These are sized in terms of BTU per hour output, okay? And a napkin math for a system might be to start with, for every 600 square feet, you need about 12,000 BTU per hour of output. On top of that, you might consider the age of the house, insulation, windows, solar gain, hot and cold spots, and etc. Next thing you need is airflow, of course. If you have a really big system in a small room, it leads to inefficiencies. So are there closed doors? Are there many small rooms? Or are there other limits to airflow? And capacity, oh my, capacity is a big consideration with these systems. There's what we call rated capacity, like a 9,000 or 12,000 BTU rated system, which is a bit misleading at times. There's a connected capacity. What we really want to understand is the capacity at ambient temperature. Is this system going to work when it's really cold or when it's really hot? And there's minimum and maximum capacities. So the key point I want to convey here is it's really better to rely on some engineering data. And the advice is to not try and overthink or plan this part. Let a qualified rep help. And meantime, it's not an exact science, so you don't want to try and overthink it. Oftentimes a 9K or a 12K indoor head will just do a great job. Regarding pesky details, of course, besides the indoor unit locations, you've got to determine an outdoor unit location. You've got to map out the line set runs to connect the indoor and outdoor component. You've got to consider condensation drain, referring back to that ice water analogy. You need dedicated electrical running from the electrical panel. And sometimes even a HOA or city planning and zoning limits come into play. Bells and whistles, you can add Wi-Fi to these systems and possibly some aftermarket air quality systems. That's about it. Okay, moving to the idea of configurations when you're looking at this question. So we're going to see different examples of different applications, but I want to point out that it does mention ducting down here. So what is ducted ductless? We'll have to talk about that. And finally, what's the right move for you? You have to think about what you're trying to achieve and what are the main concerns and go from there. There's a number of options depending on the specific need. And note there's also outliers within and between brands that shine in specific applications. For example, cold weather performance, efficiency, and so forth. So again, a good qualified rep can help you with this. Don't overthink it and you'll love your ductless system. Okay, so we've talked about different configurations, single zone or multi-zone. And a zone is a fancy word for a room, right? Or a zone can refer to an open floor plan, a combined living, kitchen, and dining area, for example, often called the main zone. So this image shows a multi-zone system and it has refrigerant piping running to multiple rooms and presumably has the BTU per hour output to serve those rooms. So here's the key. is there's two components to comfort. They are A, having the correct BTU per hour output, and B, having airflow. A good fit occurs with both BTU per hour output and an area that allows the system to move the air. If you have a 1,500 square foot zone, it may be fine with a one zone system, a single zone. However, this square footage cut up into many rooms with little airflow, and you'll probably need a different solution. On the left here, you see some Daikin, what we call high wall indoor units, and they're now commonly seen in homes and offices, coffee shops, and conference rooms and the like. On the top right is an example of a ductless recessed cassette. These fit into drop ceilings and are often used in residential homes, maybe requiring some joist reframing in the ceiling. These work well when there's little wall space. And finally, we have low wall units. I've seen these most often used in attics where you have a knee wall going up to a pitched ceiling, and the low wall is a great fit in that situation. And final note on these is you can mix and match these in a multi-zone system. So high wall downstairs, low wall upstairs, for example. Okay, and back to this idea of ducted ductless. What the heck? So here is an indoor unit that uses the same outdoor unit as the ductless options. The refrigerant pipe runs to the mini ducted unit, which then uses forced air to deliver heat or cooling to multiple rooms. It's called a mini ducted or concealed unit. And you can mix and match, again, mini ducted with ductless units in other parts of a house. Some of the benefits of this is that it can save on the cost of installing multiple ductless indoor heads. It allows for a single refrigerant line run. It can be a better fit for many small rooms in the same area. And potentially it's an aesthetics consideration if you'd rather see a vent grill on your ceiling rather than a ductless unit on a wall. It's not as efficient as a ductless system, especially if it's outside of the envelope of the house. There's some code actually changing locally on that they would be within an insulated space. It's a single zone, so all of the rooms fed by this system get the same air, so you don't have the option to turn on or off air in different rooms or change temperature. And of course, you need a sizable attic access point and clearance in the attic to fit. Okay, so here's an example of our next indoor unit option, which is a central air handler changeout. If you have an older, inefficient central furnace, and you can change out the existing gas system and possibly a conventional heat pump or AC unit connected to that and put in an inverter system. So you'd be rid of the fossil fuel burning system and running on electric. Technically, this is a ducted heat pump, but the inverter technology and electric source is the upgrade. And here's an example with the same house on the left and on the right. We removed the gas system and installed an inverter central air handler using the existing ductwork. On the left, you see the white exhaust piping. That's for the gas system emissions. And on the right, you see those white refrigerant lines for the inverter heat pump system, having no emissions, at least locally. So installing a new high efficiency gas furnace with a conventional heat pump is about equivalent in cost to installing an inverter central system. If your house already has ductwork and it's in decent shape, this might be your best option. And here's the outdoor unit for that central system changeout. You see our inverter heat pump. Okay, so to look again, is this the right solution for you? If you're considering a new addition to your house, it's a great choice. If the upstairs bedroom is too hot, you might think about putting in a one zone system to that room. If you have wall heat in all the rooms and no ductwork, then probably yes, go ductless for sure. You could save on cost by keeping wall heat in some of the rooms. So you could get a multi-zone for maybe the main rooms or the rooms that you use the most. Basements don't typically need cooling. If you don't spend a lot of time there, using electric heaters occasionally is okay. And if the existing central ducts are in good shape, then you might consider a central change out in the future. So there's no one best solution, but there's a number of great options. So determine what is your heat and cold tolerance and what's your budget. The best approach is to balance comfort and cost. Okay, choosing a contractor. So let's look at the customer. The customer, of course, wants to be comfortable and not pay a fortune getting there. Otherwise, they might be interested in efficiency and the environment. So go electrification. Of course, how much is it going to cost? There's a comfort cost balance. Don't need AC in the basement, cooling in the basement, excuse me. Adding zones and custom work adds to cost. As far as how much, also think about the brand and utility promotions. They're really no joke. And you can save a bundle of money. So be sure to ask about promotions and rebates. Another customer interest, of course, is can I get it today? Scheduling is usually a couple weeks to a month or more out, depending on the time of year, and can take 4 hours to 3 days to put a system in, depending on the job. So consider off-peak time for scheduling if you go with a job. And of course, the 3 bids rule is another gamble. You can easily get 3 high-cost bids. So determine what you need, learn about your options, and choose a good contractor. Locally in Portland, Oregon, there's a list of trade allies with the utility, and they are all committed to best practices. And then finally, the contractor wants to offer you guarantees or warranties. They could offer financing. A main point I want to convey is that it really depends on the entire team when you're selecting a contractor. The company has to have experience, the rep has to have experience, the installer needs experience, the electricians, the subcontractors, and etc. So everyone really contributes to a good customer experience. Another question for a contractor is there a showroom you can go to and see a working model, see and hear a working model? And then finally, just as important is, does the contractor serve a multilingual customer? The heat pump store is a woman's business enterprise, and we are working on Spanish language forms and guides, and feel it's good business and a commitment to BIPOC communities. Excuse me. Okay, so finally, other resources. You can try and find some HVAC insiders to talk with. Your best bet is to talk with an experienced sales rep. At least locally, our utility is a great resource. So look at a website, ask about environmental programs. Utilities are interested in energy conservation and give support and information and rebates to a lot of people who might be interested in these systems. Finally, as far as reviews are concerned, look your contractor up online and see if they back their work. All right, and then briefly we'll go through energy and the environment. First thing to mention, again, in Oregon and Washington, we think of our electric utilities as a partner in our work. Programs specific to us in Portland fall under the Energy Trust of Oregon. And one of their websites offer that you can cut your heating costs up to 40% compared to a standard electric furnace or an electric baseboard. And in our work, we've even heard of times when our customer has financed an installation, making monthly payments, and they're still saving money because of their electric bill. And I'm going to jump through here real quick. Inverter systems are super efficient. Here's an energy guide. Talks about efficiency ratings. A SEER rating or an HSPF is what you want to look for in a high number. This is a review showing 2 million BTUs of energy savings in the Portland area region because of heat pumps displacing electric resistance heat. Portland also has an energy score for new home sales, comparing one house to another, and trying to get a good energy score ductless system will help. Finally, I believe in the science of human-caused climate change, and with the big heat dome and 116-degree weather we had in Portland recently, we're seeing native plants around affected by this supposed once-in-a-millennium event. Hopefully it doesn't happen any more often than that. Last couple of slides, a little puzzle for you, inviting you to join the ductless revolution. And I'll throw one last in here, suggesting that you join the Electrify revolution. Thanks very much.
Thanks, Tim.
Brian, a quick reminder to folks that we will be sending Tim's slides to everyone afterwards. There's a lot of great info in there that I'm sure people want to look at. Great. So should we kick it over to Len then?
Yeah, let's do that.
Okay, screen share here. Everybody got that?
Yeah.
Thank you. First of all, thank you for allowing me to talk to you all here today, and good afternoon, good morning, wherever you may be coming from. I'd like to take a few minutes and kind of talk to you about industry trends and the way that the whole thing looks from a a manufacturing point of view, more nationally and even globally a bit, and specifically Pacific Northwest. I know there's a lot of you from the PNW here today. So how do heat pumps fit in with this moving forward HVAC industry? It's with the electrification movement fully on, as you all know, this technology is going to become more and more prevalent, and it's already happening with technology advancements and the ability to operate in different ambient conditions. It's becoming a bit of a no-brainer in most cases. The fossil fuel trends that we're seeing, globally and in the U.S. and the Pacific Northwest specifically, are showing that this electrification is picking up speed again, as you all know. I mean, we're seeing a lot of municipalities actually making moves to, if they haven't already, to ban installations of gas furnaces and the like in new construction projects. We're seeing that in a lot of states, and a lot of them where you probably are coming from: Rhode Island, California, New York, Massachusetts. The city of Denver is an example. Here in Washington, where I live, Seattle, Bellingham, Thurston County, which includes Olympia, Lacey, and places like that. The state of Washington is actually have a House bill on the floor being considered for a statewide movement, which is, I believe, the first in the country. So we're really starting to see this pick up speed. So the electrification movement is definitely on. Kind of a global look at the adoption of heat pumps, and Tim touched on this a little bit, but heat pumps are certainly nothing new. The technology advancements are picking up speed, and just as some examples, in Japan, over 90% of households are conditioned by a heat pump, and nearly 100% of those are inverter driven. So I would definitely encourage you to do some research on inverter drives. We won't have time to do a deep dive today, and I don't want to get too far in the weeds, but I would definitely encourage you to do a little research by yourselves on inverter driven equipment. The global heat pump market is projected to nearly double by 2026. So that alone tells you the adoption of this is far and wide. Another example, in the UK, heat pump installs are targeted to increase 20 times to approximately 600,000 annually. So there's no question that this technology is definitely gaining ground. In the U.S. Specifically, sales of heat pumps, and specifically ductless heat pumps in the U.S. is increasing drastically year over year. We see some spots where year-over-year sales numbers are north of 40% increase. So it's amazing to watch, actually. So you wonder what's driving all that. A lot of it is just awareness. Some places in the country are a little bit ahead of the curve in adopting these newer technologies. Some not so much. But we're seeing it widespread nationally, where places that weren't, so quick to adopt these technologies are now really jumping on board. Utility incentives, rebates are a big driver of these. The efficiency numbers qualify for most of these really high incentives and rebates. Technology advancements, meaning better performance at extreme conditions. High ambient cooling, low ambient heating, has brought heat pumps to places where people were uncomfortable using them before for these reasons. The addition of different styles of indoor units and options, and Tim touched on this a little bit, wall mount units, floor mount units, ceiling cassette units, in some cases, ducted units even. So you really have the ability to configure these systems to your specific needs and your lifestyle. Multi-zone whole home solutions is also becoming a really big part of this, just due to the a lot of the, again, rebates and efficiency numbers and just making the whole smart home approach. Internet of Things, these units are most of the time compatible with home management systems. Just a lot of things to consider when you're looking at stuff like this. So what do you look for in a ductless heat pump? Solid warranties is a big one. 10 to 12 year limited warranties are the industry standard anymore. I'm not 100% sure about every manufacturer out there, but most of the major ones have 10 to 12 year limited warranties. Efficiency ratings, Tim kind of touched on this as well. SEER ratings is a cooling metric. HSPF is a heating metric. This is a formula of power input in relation to capacity output. Higher the better. Also, as a caveat to that, as I encourage you to do research on inverter-driven equipment, I would encourage you to consider the efficiency ratings of that equipment. Those SEER and HSPF ratings are based on single speed operation of a unit, not an inverter drive. So the efficiency, the actual efficiencies you could realize in the real world could far exceed those ratings. Performance ratings. This kind of speaks to the low ambient heating and the high ambient cooling that we talked about. How much is my system going to derate at different ambient temperatures? Very important to understand that, depending on where you live and what your application is. Sound ratings, also very important. We find a lot of municipalities with sound restrictions now. We see a lot of really close lot lines in most, residential subdivisions. Just kind of as an example, obviously lower dB levels are quieter. So just kind of some reference on that. 140 decibels is as if you were sitting in the front row at a rock concert. If you're making margaritas or daiquiris, your blender's running about 100 decibels. Conversational speech like we have right now is about 60 decibels. So there are many ductless heat pump outdoor units that will run in the mid 50 decibel range. So extremely quiet. We touched on this, the availability and styles of indoor units. Does this manufacturer have a wide selection of different styles of indoors? Could really come into play. And then of course a quality installation is key. If it's not installed properly, it's not going to perform the way it should. And as with anything, proper installation is just imperative to getting out of the unit what you expect from it. I wanted to touch a little bit on low ambient heating specifically, because this has really been one of the big barriers to heat pumps in these conditions. So unequivocally, the answer is yes. You can use these in low ambient climate zones. There are systems that are designed specifically for this purpose. Technology advancements allow this, and I won't get into the weeds on all that. But here's an example of one extended capacity unit. And as you can see, 47 degrees is the standard for rating capacities across the board on any HVAC equipment. So in this case, this unit is a 1 ton of 12,000 BTU. So at 47 degrees, it's providing 13,400 BTUs of heat. As you can see, at 5 degrees, it's actually still overperforming its 47 degree rating. And that's due to the inverter drive and its ability to overspin. Again, not going to get all techno on you, but this is the benefit of inverter driven, low ambient capable equipment. Operating range all the way down to minus 13 degrees. So, I mean, I would still recommend in some places, you're always going to want to have some source of backup heat, but they're fully operational down to minus 13. So you'll be derated a bit, but you will get substantial heat still, even to those really low ambient conditions. There's an example of some of the climate zones in the US specifically, even into the 6 climate zone and the 7 climate zones up in the north Midwest there into Montana. Substantial cold temperatures there, but these units are being used more and more even in these really, really cold climate zones. So, I mean, I guess the point of that is, feel confident that this unit will perform even in your conditions. And conversely, into the warmer, more humid parts, they will overperform as well in those kind of conditions. Longer run times, better humidity control. There's a lot of advantages to ductless heat pump and inverter drive specifically in all of these climate zones. And real quickly, I don't want to keep you over, but with all this, comes concerns of refrigerants, and specifically newer refrigerants coming with the new federal guidelines set to hit in 2023. So you'll see R32, and others may develop different refrigerants, but R32 seems to be the widely accepted replacement. It's widely globally been in use for quite some time. It's very widely adopted. There's over 100 million systems that have been safely installed and deployed globally with this refrigerant. Just a couple high-level points. It is 12% more efficient than 410A, which is what's widely currently in use. It's got a 68% lower global warming potential than 410A. So, I mean, these things are really big in this industry. and this R32 is already widely used in many other refrigerant blends, 410A, for example. So do some research on that as well. I would encourage you to do that. I'd refer you to this website listed below, www.r32reasons.com. And there are literally 32 boxes on that web page that will answer many questions and bring to light many things you may have not considered, and really put you at ease and your mind to rest on refrigerants as a whole, and R32 specifically, with some of the concerns people may have with something new. So with that, I will hand it back to you all. And thank you for your time.
Great. Thanks, guys. That was fantastic. We have about 10 minutes or so, maybe a little bit more than that for questions. And Joe, do you have any that caught your eye there that we want to ask these guys about?
Yeah, sure. I think we kept seeing this a little bit, and Len was responding in the chat, but could you guys just speak briefly on the maintenance required with these, with ductless heat pumps?
Yeah, so very minimal maintenance actually, as opposed to some styles of systems. Basically, with a ductless heat pump, you're going to want to keep the outdoor unit clean, the condenser coil clean, periodically check, electrical connections, those type of things. Make sure rodents or something hasn't, doesn't chew on wires. Keep your indoor evaporator filter clean, coil if necessary. But other than that, there's no belts to grease, no bearings to grease, none of that type of thing. It's basically cleaning.
Yeah, we had a lot of questions. I mean, and I think actually just to, typically a lot of the installers will have maintenance contracts available to you. And I recommend that because, it's like we've had situations where, you just, when they come out, they'll make sure it's working, and maybe it might need an adjustment or a pressure adjustment in the coolant lines or whatever it is. And so, it's like any piece of equipment, you want to maintain it, but it's not outrageous, and it's really not a lot more than you would want to do if you had a gas furnace. That needs maintenance as well. So, but yes, it's you want to make sure that it's working well. We've had a lot of questions about air filtration, because in whether these units can do air filtration, and also questions about energy recovery, ventilation. Could you guys just maybe speak to that a little bit?
Sure. So filtration, with a ductless unit, they do have filters in them. They are not a super high MERV rating, however. But with the technology as it is, you have a continuous airflow that brings the air across that filter constantly, which cleans it. With a ducted mini split, as Tim touched on, you have traditional induct filters that you can use with a higher MERV rating, MERV 11, MERV 13, whatever the case may be. So the answer is really both. Regarding ERVs, yes, we actually see quite a few actually, ERV applications with mini splits. If it's a ductless system, the ERV would need its own air delivery system somehow to deposit the air and extract it from the house. But if it's a ducted mini split, then you can drop that air right into the ductwork of the unit itself.
Yeah, I mean, here, okay, I'll just use our room for example. So this is this building I'm in has two big rooms, and it's got two of those heads like that up there. So it's a multi-zone, and one system outside, two of those heads. Last year we had really bad wildfires here, and I'm an air filter geek. So you can see see that little thing right there? That's an air particulate monitor. So I was able to measure the indoor air quality here when we had those wildfire events, and it was off the charts in terms of how bad it was. This mini split couldn't keep up with that because it, like Len says, it doesn't have those really advanced filters like our ducted system that we have in our main house. You know, we're in a little ADU here. In our main house, we have HEPA filters and all sorts of stuff. You can do that if you want with a ducted system. It's harder with these, but I'm a big fan of, let me show you this over here in the corner. See that little guy right there? Oh gosh, got so much stuff in the way. See that unit right there? That's a small portable air filter. Blue Air makes them. I'm a big fan of them. I think that thing costs $150. It's got to have a filter in. And when I turned that thing on during that wildfire event I was talking about, I could take the indoor air quality from 400, which was, you know, that's super dangerous, to under 50, which is what you want. And so that little unit took care of this whole building on it. So I would say with ducted systems, you probably, if you really have air quality issues, you probably want a secondary filter. But they're not expensive, so don't let that, and they're quiet. They're really quiet. I mean, we sleep with it going. So yeah.
And I would just say, Tim, when we were talking earlier, you said to me that in Asia, those are considered separate systems, the air filter.
Sure. Yeah, whether it's whole home or whether there's an air filtration dedicated to each room, my understanding is that's the practice.
Yeah.
Cool.
Can either of you guys comment on, there were some questions about building those units into the wall just as a kind of, just for a visual reasons. Do you guys see that?
Sure. I've seen applications where they would be recessed into a wall, built into a soffit or something of that nature. Having a cabinet kind of built around it, as long as you follow the airflow requirements and clearances, you can do all sort of creative things.
Cool. Okay, great. So we got a couple questions on this, on the inverter. We talked about that. I know we're getting a little technical versus the conventional, and I wanted to then bring up ducted versus ductless. When I was talking to Tim ahead of time, it seems like the ductless systems are all inverter, and that means they're more efficient. They have a lot better ratings. Whereas the ducted ones, they don't have to be conventional. They don't and less efficient, but most of them are. So could you guys comment on those two things, ducted and ductless, inverter and conventional?
You want me to address that, Tim?
Yeah, give it a run.
So when you look at efficiency ratings with a ducted versus a ductless, the outdoor unit is the same. In some cases, you'll see a slightly lower efficiency rating on a ducted system because that takes into account duct loss with the airflow, where the ductless does not have that element. Inverter versus single speed, I would use an analogy, just not to get too far into the weeds technically. Your car, for example, cruise control. The way a cruise control works, just for a quick example, you're getting ready to get onto the highway and you're on the on-ramp. You're gonna, basically hammer down on your throttle pretty hard to get your car up to speed to merge into traffic at 60, 70, wherever the speed limit is where you are. You merge in traffic, you push the cruise control button. So your car is cruising along at 70, let's say. So you're on flat ground, you come to an uphill section of the highway. What does your car do? It kind of accelerates a little bit to keep that speed at 70. So then conversely, you head on the downhill side of that hill, what does it do? It throttles back a little bit to maintain that 70-degree speed. An inverter is very much like that. But instead of controlling speed, we're controlling temperature, and we're modulating compressor rotation speed, electronic valve position, indoor fan speed, all these things together to keep, I don't want to get too technical, but to keep all the metrics where they need to be to use less energy. We run the compressors more slowly. We run the fans more slowly. We modulate refrigerant flow with an electronic valve, and it all comes together to use less energy based on ambient and indoor load conditions.
And just, you know, one thing about that too is you will notice that from a comfort standpoint too. I mean, that I think it's, you know, typical furnace systems, particularly the older ones, you know, you will see these big spikes where the furnace will come on and blast all this hot air. So the temperature inside, if you have it, your thermostat set at 70, may get to 73 degrees or so, then it'll shut off. And then your house will cool down to like 67, 68, and then it'll turn back on. So you'll see, it's pretty typical to see like a 4 to 6 degree temperature fluctuation in your home as your gas furnace is turning on and off. And you will notice that. You will, and when you have one of these inverter systems and you set it to 70, it's going to be 70 degrees pretty much constantly. And that's a very attractive comfort proposition, let me tell you. I mean, you will notice it, and you'll feel that.
All the ductless ones are inverters driven, and so they're more efficient. That is one of the takeaways.
Right.
Can you guys just comment a little bit more on this SEER and HSPF thing? I mean, I know you touched a little bit on it, Tim, but like, it's basically the bigger the number, the better, right? But yeah. In general, kind of what do people want to be looking for here with a ductless system?
Sure. So SEER is an acronym for Seasonal Energy Efficiency Ratio. We see numbers in the high 20s. Does that sound about right, Len, for the highest SEER numbers?
Yeah.
HSPF, Heating Seasonal Performance Factor, is related to the heating efficiency. We look at both because, of course, we have our different seasons, and the ductless system will do both heating and cooling. At least in the Oregon and Southwest Washington, the HSPF is going to be a more important number because we have more heating need throughout the year than cooling need. The local utilities, when they look at rebate programs, require a 9.0 or better, typically, for our HSPF number. On single zone systems, I've seen HSPF up into the range of 14. So the higher number, the better. The difference that's you know, I think it is an important point is if you're comparing a couple of systems and they've got, of course, different HSPF ratings, paying more for the system with a higher HSPF can pay you back over the life of the equipment in energy efficiency. So a little more expenditure up front might be a good way to go.
Do you find that's usually the case? You spend a little more up front for the more efficient, but then you save on your electrical bills and you recoup that cost?
Yeah, I think that's certainly true. A lot of it comes down to how a person uses their system. So we try and be vague about some of those answers. You know, as far as like how many dollars are you going to save, for example, hard to say. We certainly have best practices that we share on how to use these systems. For example, like Len was saying with the sort of flat modulation of an inverter system, it's better, at least in the main zone, to turn it on and let it run and just let it do its thing.
A quick question on the electrical supply. Can you do it with, do you need a 60 amp breaker? Someone is asking, can you do it on a 100 amp panel, a ductless heat pump?
Mm-hmm.
So, go ahead, Tim. You can.
Yeah, sure. Thanks, Len. So yes and yes. A single zone system might take a 15 amp circuit. Larger systems, maybe 35 amp, at least on a residential system. An electrician can change the breaker out at the panel, or oftentimes there's an outdoor disconnect box where it can be fused down in a sense. It requires a 240 volt dedicated circuit. On a 100 amp panel, you know, if you're putting in a single zone system, it's likely a smaller house. 15 amp out of that 100 is not a whole lot of draw. So it's usually a great fit.
What's the story with thermostats with these things? I know our system just has a little, just has this kind of device that we use to control it. But can you connect them to like Nests or other kind of thermostats? Is that a thing?
Yeah, I can't speak for all manufacturers, but some, yes. Daikin, yes. But there are anything ranging from what you just showed there all the way to smart controllers. It just depends on the level of the equipment and the manufacturer, what they have available for controls. It's very important to consider, you know, some of these controls, as you know, geofencing, the ability to integrate OpenADR 2.0, which is a software that a lot of utilities use, so they can take a look at things, you know, on peak demand and stuff like that. These things are all coming, so the controls aspect is another important thing to consider.
Yeah, those smart thermostats can be really nice because you can turn them on and off from, you know, miles away, which can be really nice. You know, if you have one in a situation where you're coming and going from your house frequently, you can control temperature from far away. That can be really nice.
Yeah.
A question that might be a good concluding question. You know, in the Oregon region, we know there are a couple of great installers. Of course, a huge plug for the heat pump store. They're coming to service my heat pump in a couple of weeks. So huge plug for them. But you know, folks are coming in from all over the United States and the world. You know, Len and Tim, if you guys have any resources, where can people find, you know, good installers of ductless heat pumps?
I can speak for Daikin. If you go to www.daikincomfort.com, there is a dealer locator that will drive you to dealers in your local area. I would assume that all manufacturers have something similar.
Great.
That's a really good resource, and we'll make sure that we put that in our follow-up email to everyone. But it's true. I also, the Electrify Now website, if you're in the Oregon area, you know, we have a contractors page. Heat pump stores on there. We have a couple other suppliers, but you know, if you contact them through, give the Electrify Now name, you'll get a little discount, which is nice. But we put them on there primarily so that you'll know who to trust, because you know, you can get some bad advice from people. I think in general, heat pumps are becoming more and more available and, you know, known. So a lot of good HVAC people are doing this. But you want to talk to somebody who's done a lot of them, because they're going to give you the best service, they're going to give you better pricing, and they're going to make sure you're happy. I love the Daikin reference, because they, you know, if it's on the Daikin website, it means that those people are putting in lots of Daikin units, and that means that they're experienced. So that's a good resource. We'll put those in a follow-up.
Great.
Yeah. So Joe, how are we doing? Are we? I think we're over our time here.
Like every good webinar, we're over time. But...
Yeah, a lot of good questions. I really appreciate it, Tim. Thank you so much, Len. Really appreciate your time, both of you guys. All of you in the audience here, you know, I encourage you to check out Electrify Now for more information about all this stuff, and again, the contractors page for sure. It can give you some good resources here in the Oregon area. And Joe, anything else?
Well, of course, we always leave you with good luck with your electrification projects, and huge thanks to Len and Tim.
Thank you.
Thanks, everybody.
Thank you.